Greetings. My name is Dr. Jace Hargis, and I'm very fortunate to be the director here at the HCT Abu Dhabi Women's College. Today I would like to share with you a very brief video to enhance our conversation in the classroom on the biogeochemical cycles. Now, the one main thing, if you leave with only one point, is to really focus on this concept of cycles. So everything that we're going to be talking about, although it may have some vocabulary that may be a bit strange or new to you, it all is about these cycles, which means that everything rotates around, everything goes from one part to another. So it's key to realize that for things to happen is that during these cycles, round and round, is that various aspects of nature will either prevent or promote one form of these chemicals going to another. So I'll be discussing with you the hydrologic cycle, the carbon cycle, the nitrogen cycle, the phosphorus cycle. Again, try really hard not to get caught up in these. You'll find that if you can just kind of determine a process, and the process is that everything goes around and around and around, what you need to focus in on what enables that to continue and what maybe prevents that, and we'll talk about some of those. But the first is the hydrologic cycle, which is known as the water cycle. We all know this and have seen this. But basically, water is going to be rotated throughout our Earth. Some portions of the Earth, a lot of water. Some portions of the Earth, not as much water. Basically, these pools of water, reservoirs of water, are going to be moved around by processes such as evaporation, water coming out of a particular reservoir, condensation, coming back down, precipitation, infiltration, runoff, subsurface flow. Once again, I'm going to encourage you probably a dozen times, don't worry about the words, worry about the process. This water actually happens to occur in various phases. We all know probably the standard phases of a liquid, a solid, and a gas. Again, the phases are important because they allow and enable those water to move through those processes more quickly. So the biggest one probably is the water cycle. The second one, which is really essential to life, is the carbon cycle. Carbon, as you know, the elemental carbon represents life, organic. Anything with carbon in it is considered organic. Anything without carbon in it is considered inorganic. Carbon cycle follows, again, these cycles. The cycles, along with the water cycles and the nitrogen cycles, create this sequence of moving carbon around. If we can think about the air that we breathe, much of it is carbon dioxide. Yes, there's oxygen, there's nitrogen in there, but a lot of it is carbon dioxide, and that is transformed into various things. There's carbon in carbonic acid, which comes with the rain. There's carbon in glucose or sugars. Of course, coal, and even diamond and graphite, they have carbon in them. The difference of this carbon is in the various forms, what they're connected or bonded to, and ultimately their bond length, or how closely compressed those carbon atoms are from one to the next. One thing you might want to think about when you think about carbon is this whole idea of a photosynthetic equation. I'm sure you've heard about this in your schooling. This is how plants take light and create energy, how they create their own substance. So basically they pull out from the air carbon dioxide, CO2, they mix that with a little water, H2O, and they magically create this glucose, which is a combination of some carbon and some hydrogen and some oxygen, and then they release, as we all know and we enjoy, some oxygen, O2, diatomic molecule. The bottom line here is that this carbon, you can see very quickly in its basic form, has gone from a CO2 bonded with two oxygens, and is somehow merged and created together into a C6H12O6 compound, which is this glucose. Again, a very powerful molecule. The next cycle would be the nitrogen cycle, and these aren't, these don't exist in their own rights. They all kind of intermingle. So you have the water, you have the carbon, you have the nitrogen. These are all kind of going on at the same time. Nitrogen is really key. We all know that the atmosphere is made up of 90% nitrogen, so there's a lot of nitrogen out there. The challenge with nitrogen, although that is plentiful, is that it is only in certain states, only in certain ways and phases that we can actually use it, us, animals, bacteria. So there has to be something done to the nitrogen. And through this cycling process, we can fix it. There's actually something called nitrogen fixation, which takes it from one form to the next form. There is nitrification. There's denitrification. So it's adding and taking away oxygens, NO2s, NO3s, NH4s, NH3s. These are all ways to combine these molecules in different ways. And the whole point of this cycle is so that different things can use them. Bacteria may use it in one way, animals may use it in another way, but it's all about walking through this process. The final cycle, and these are the nutrient cycles, the nitrogen and the phosphorus. These are essential nutrients that we need for living, is the phosphorus cycle, represented as P, but it's typically exists in a form called phosphate, PO4-3. And the whole point of the phosphate is that it's actually given off to allow things to live and use as a nutrient. Most of the 80% of our mined phosphorus is used for fertilizers. Again, the fertilizers then would be a nutrient for plants to grow, animals to eat. We also derive phosphorus from sewage. Detergents are a really popular source of phosphorus. So these are the basics of the cycles. Now, where do the cycles go? Well, we have them go in the air, in the atmosphere. We have them go on the land. We ultimately have them go in what's called the subsurface and the surface soils. We talk a lot about soil. Some people call it dirt, but keep in mind that the soil is key. This loosely weathered rock organic is the subsurface soil. It contains three parts, basically: sand, clay, and silt. And it may seem like we've shifted gears from cycles, but again, I mentioned that the cycles really play a role in transforming. So it depends upon where this particular carbon, phosphorus, or nitrogen exists in the sand, clay, and silt, is how it's going to be basically transformed or fixed from one to the next. Ultimately, we have the first layer, which is an organic layer. This is kind of the leaf litter, and the organics are going to be the very, very top layer, which will be at the surface. We then have a topsoil layer, which is going to be varying amounts of organic, but still very high in organic. A subsurface soil, which is just below that organic top layer, a little more dense, a little bit lower in organic. And then ultimately this transition zone between the organic and the partially weathered parent rock. And then at the very bottom, which is basically going to kind of keep it all intact, is the bedrock.